Looks like everybody's in, Paul, pretty much. So
All right,
let's get started. Let's get started for those that are here on time. I want to thank everybody for coming today. This is Don Hope. I'm the Director of Business Development for Columbus Advanced Manufacturing Systems. I'm going to be joined today with Paul Kutolowski. He's our application engineer, SolidWorks engineer. I'll let Paul introduce himself in a little bit. But I'm the Director of Business Development. I've been working in the SolidWorks channel for over 18 years, working with people with their CAD and CAM issues and helping them grow their businesses. And today we're blessed to have Mr. Kutolowski presenting. And he's put together a really nice presentation for you. Recently, if you notice the cowboy hat in my picture there, I developed a machine called a mechanical roping machine to train my horses. And I didn't realize how hard it was going to be to do something like that. And one of the things that the original engineer did was he came out with a tablet or something. He took pictures of some stuff, and then he started marking on some stuff. And I don't know how he did it, but anyway, he put it all together. And Paul's going to show you how that process can be done today to help reverse engineer some things and do some creative things and get more out of your SolidWorks investment. So with that, I'm going to go ahead and turn it over to Mr. Kutolowski. And at the end, we'll have some questions and chats at the end. You can put your chat questions on the thing, or you can email us later. And this will be recorded so that everybody can take a look at it and share it with their fellow workers that aren't able to watch today. So Paul, it's all yours.
Thank you very much. Don is in particular interest of this reverse engineering because the rest of that story that he told you includes a portion of the payment of an exorbitant amount of money for something that you're going to find out today is very, very simple to do, pretty easy, and as he saw, part of it involves taking a picture and making sure you've got one good dimension. So we'll talk about. So with that, we're going to get into reverse engineering. Now, check out my agenda. Very first thing is splines. So what's that all about? Reverse engineering can be really boiled down into two specific areas. And Don mentioned the first one earlier. That is taking a good digital photograph of the part that you want to make. You may find this thing on the roadside as you're driving to work someday, or find something that you really have no documentation to support and to remanufacture. So what's really required are two things: a good digital photograph, and that would be from a plan view, right? I mean, so you're not taking this picture from a perspective or something like that, because ultimately what you're going to do is import that photograph into SolidWorks. You're going to bring it in probably as a JPEG or a bitmap, depending on whatever format you're accessible to, and then you're going to trace it. That's it. You're going to take a photograph of it and you're going to trace it. But the question then becomes, what scale is that? How big is it? And that's when that dimension that Don had mentioned too comes into play, because what that dimension is going to do is help you set the scale. And we're going to see that in a little bit. Now, under normal circumstances, if your part is pretty linear, okay, it's all straight lines, you may have an arc here or a chamfer there or something like that. Those can be added very, very easily. But, and that's why we're coming to splines, what if it's not? What if it's some kind of origami thing? What if it's some sort of a thing that's got no straight lines, and it's all curves? How are you going to replicate that? That's very, very difficult, very challenging with some of the designs that people are trying to copy today. And so that's where splines are going to come in. Splines generally are a feature, are a tool within SolidWorks that a lot of people do not use or don't use very often, so they're kind of forgotten about. And so I thought it would be a good idea to jump into this this week and talk about splines and how they can be used to trace, if you will, those particularly challenging, weird shapes that are pretty pretty difficult to do. And so we're going to talk about splines. What are they and why they're so hard to control? How can you fully dimension them? A lot of people don't dimension splines. And that becomes problematic down the road, as someone else can look over your shoulder and then take a look at your design and change it quite accidentally. There's a great number of spline tools. We'll be talking about most of those. So that's when, with a little bit of that background, we're going to do some reverse engineering. I'm going to show you how to import that JPEG and adjust it for the correct scale, and then trace it. Okay, and then we're going to get into some questions and answers. So let's go ahead and do this. So with a pinch of luck, here we go. And hopefully everybody is looking at my SolidWorks screen. And what I'm going to be doing today too is showing you how to do this, but also showing you using shortcuts. Okay. You're going to find that I'm not going to be using this toolbar up here very much. Every once in a while, maybe, okay? But the whole idea is to get away from that. For the last several years, SolidWorks has been introducing more and new tools to allow you to get through your design day faster and easier by using shortcuts. So I'm going to be taking advantage of those things today too. If you want to know a little more about those, put that in the chat as well. Okay, so splines. Very simply put, I'm going to create a spline here, and the way I'm going to do this is 1, 2 points, just like that. Okay, so that's my first and foremost basic 2-point spline, the easiest spline that you're going to be able to create. As I bring my cursor over to this, you notice that the cursor is indicating that that is a spline. And as such, when I left click on it, you're going to see it's got some what's called spline control handles. That control handle emanates from each point in both directions. And in light of the fact that I only have a 2-point spline, there's only one direction that they're pointing, and that's from that point that it's emanating from back into the other spline. If there were a spline, as you'll see later here, or a connection point here, there would be arrows on both sides. So each control handle has 3 little features on it that you use to control it. One is this diamond. Another is this triangle, or like arrowhead, and one is a point at the very end. And you use them by left clicking on them and holding the left mouse button down and pulling it. Okay, so the first thing that I'm holding on to is the diamond, and you're seeing a little value there. If you can read that, it says about 10.6 degrees, and what that's telling me is that I've just moved it 10.6 degrees. For example, if I leave it there for a second and then move it again, it's telling me I've moved it 7, but that's 7 from where I started from, and that's really kind of an academic thing, but it's a point of reference. Okay, so the diamond is giving you the ability to control the angle of the direction vector from this point. Okay, it's not of the line. Everything is being driven from the point from which this thing is emanating from. Okay, the next one is this triangle, and the triangle adjusts the magnitude of that vector. Okay, so I can pull this in one direction only. You'll notice that the diamond only sweeps back and forth. I can't go in and out or anything like that. So it's only working the angle. The triangle right here is just working the magnitude. I can't move it side to side. So the missing link right here is this point, and that point is going to give you the ability to combine both the angle and the magnitude. Okay, so I can move both of them like this. Okay, the other side has the same point, but understand that whatever kind of motion you're generating with the triangle or the diamond or the point, it's in relation to this point right here, okay, from where this thing emanated from where this thing started, okay? So this guy is gonna be sitting right here, and I can do all kinds of crazy stuff with it, all right? Now, like I said before, you really need to fully dimension these things, because someone can come into your model and just take a look at this line and very easily move something out of position, and you ain't never going to get it back to where it was. So if that was a particular point that you really need to hold on to, then you're going to need to fully define it. And we fully define it using our Smart Dimension tools. And for example, I'm going to come over here and define those 2 points. Notice that this guy's already emanated from the origin, so I'm good with that. Then I can come over here and pick this. And whatever that value is, that's fine. Now notice that the spline itself is black, the vertex at both ends are black, and so under other conditions, under what I would say normal conditions, the sketch is complete. And even if you look here in the design tree, there's no negative sign in front of it that says that any dimensions are missing. But if you look at the control handles, they're blue, okay? You can do better than this, is what that's saying. You can really define this. And in the case of some specific features, some specific parts that I have seen people model, this is clearly not enough dimensioning. So for some of these things, you may need to add a couple of little things like, let's get that guy back where he belongs. Okay. And we'll make that. And we'll do this guy here too. Okay, so now with the assistance of a couple of center lines, we can put in some missing dimensions. And when you're putting in dimensions relative to these control features, you're going to notice that I'm going to grab that and this line, and I have to grab this control handle by the point. And I can set that angle. And even if you adjust it, you're going to see that it is going to adjust and to be far more precise than what it was before. For that radius, I'm just going to click that point at the very end. Okay, and I can adjust it to whatever I want. I need to do the same thing on this end. And just left clicking that point right there will give me the radius. All right, now that is fully defined. Okay, that's fully defined. That's going nowhere. Okay, so we have the vertices, we've got the angles, we got the radii, we have everything fully defined. And again, as it is fully defined, it is editable. Okay, so I can come in here and change that value from 10 to 8 inches in this case, and you see the adjustment made immediately. Okay. All right, so let us look at yet another one for another feature I want to show you. And in this case, again, very simple. And we will just move the control handles up like that and pull this one back down like this. But there's another control that you have that's a little more subtle, that's a little smoother, and it's down here. Now what I'm doing to create that is I'm bringing my cursor up to the line, right-clicking, and I want to turn on Display Control Polygon. Now the control polygon is kind of a smoother, softer, if I can use the term, control. all right, it allows a little more subtle move. And when you're trying to lay this on top of something else, oftentimes you'll find that these controls here on the control handles are a little bit crude, a little rough, and you want something a little finer, and so you can do it with this. Okay, now you notice that I had to come to here, right click, and then turn it on over here. If this is something that you're going to do on a regular basis, you can come up here to System Options and then to Sketch, and you'll find that Spline Control Polygon by default can be switched on and left on. Okay, so I'm going to take advantage of that because I really like those things. They're very, very, very handy. Okay, so in a case like this, this is kind of pretty simple to do. I'm going to stretch this out here because nothing's been defined yet to show you some other features that you could add in here. Not the least of which is you can add, let's say you need a little more control in this in the central area of this spline. And so you can come in here and insert an additional spline point, just like that. Now, what you get with that is going to be the this pencil, and I'm going to put in one, but you could put in as many as you feel you need. But what's going to be nice about that is that that shows you that this guy too has his own little spline handles that come with that. Okay, and you can use that however you need it. In addition to that, you've got these guys out here. Okay, again, the whole purpose of this is to help you create that particular shape that you're looking for, however complex it may be. Okay. Okay. So in the area of more curve control, let's say we added a couple of extra spline points in here. Okay. And so we've got those guys in there. Let me show you the worst way to create a spline. The best spline has the least number of points in it. For example, if I were to do something like this to duplicate what I have here, you notice that it's kind of a mess. Okay, well, you haven't seen any mess until you try and straighten this out, because each one of these points then has its own control handles. And again, the control is based around the point where you clicked, that point that you added right there. So this is going to be an absolute nightmare and virtual impossibility to duplicate this curve with. Okay, so the secret to success in using splines is the fewer the better. And sometimes we can get a little overzealous in the placement of these points even here, and find that this is a little more difficult than we wanted, because even with this one with 1, 2, 3, 4, 5 points in it, that's too much. So SolidWorks has been kind enough to create this tool that says simplify the spline. And in order to simplify the spline, we get this little data box that shows up in the upper left-hand corner, and we can remove some points and take this all the way back to where we originally started. So I'm going to select smooth, and I can dial this back down even to where it was originally 2 points, and say okay, and it's going to say I'm taking some points away, and that's fine. Okay, so if you get a little carried away in your zeal to create the exact curve as you were looking for, you can back up a little bit and take a couple of those points off of there. Okay. So, okay, let us go on to another type of curve, because as you saw before, when I select this guy, there's a style spline and an equation-driven spline, and I'd like to touch on those a little bit as well. So in this case, let's create a sketch, and I want to show you an equation-driven spline. So in this case, this is going to be this guy right here. And the equation can be explicit or parametric. Okay, you have your choice. And I'm going to use an explicit one in here and just type in my values. So let's say 5 times sine of x from 0 to 50 ought to do it. Green check. That's a spline. Okay, so that's the equation, or the solution to the equation. If you hover your cursor over it, you can see that it's indicating that it's been driven by an equation. Okay, so if you need to do those, that's how you do it. Let's do a style spline. Now, a style spline is different yet again. A style spline is going to be the ideal for so many people that don't like to bother dimensioning splines, because there's no control handles. Okay, you're going to drive this strictly by these points right here. Easy enough. Notice there are no control handles. You can probably force fit them in there, but I'm not seeing it. Okay. Different situations are going to require these different answers. Let's. Okay. Yet another one is going to be a fit spline. So I'm sketching on this surface, and I'm going to sketch some lines here. Okay, so I've got 4 lines that represent something on some kind of a sketch plane, and I would like to have them enclosed in a spline. And so I'm going to take these 4 sketches here, and I'm coming up to fit spline. And when I use fit spline, I'm going to just select these things in the order I want to have them attached. Now, before I do that, if you look here in the property manager, it's going to add inflection points and the minimum radius note and the curvature combs. I am just, for the time being, going to turn those off. And then as I select them, you're going to see how SolidWorks is going to come around and incorporate my 4 sketches into a spline, wrap them into a spline, if you will. Okay. And as I say, okay, my sketch is complete. Okay. Now, how will you use that in the real world? Well, I have a little cheesy example over here of a part that is just exactly that, a cheesy little part. Don't need to make it glamorous. But anytime we use the feature, this guy right here, shaded with edges, as we create the feature, at the end of the feature, SolidWorks creates that almost to be like a surface in and of itself. All right. And this is where a style spline can actually go back and clean that all up if you really want to do that. So this is currently one face, it's one body, but as you create these sketches, SolidWorks generates these lines like this. So what I'm going to do is go back into the sketch. I'm going to edit the sketch, and you can see it's just it's a little more complex part, but a part in and of itself. I'm coming up to the sketch, right-clicking, and I'm going to say select chain. I could go back and collect each one of these points, but select chain is a real nice shortcut tool that in one click grabs the whole thing. Okay, so I've grabbed the whole sketch of this particular feature, and I'm going to say fit spline. So I'm saying take all those individual line segments, all those sketch points, and make it a spline. okay? And I jump out of the sketch and there's my body. Okay, so again, if I select this, it's all one. Okay, now please don't anybody ask me why you want to do that, because I really don't know. But there it is. If you really want to get those lines off of there, you can. And you'll notice that even with shaded with edges turned on, there are no individual lines that are running back like this. But it is a cosmetic tool that you can use to show off your part. There are some, before I get into the reverse engineering, there's one other thing I want to show about other spline controls. And so let's talk about those right now. And let's just give this a little shape to it first. And the controls that I'm most interested right now in showing you is curvature combs. Now, curvature combs are little lines that emanate from segments of the curve, and their length is helping you define the radius of the curve at that specific point. So if I go ahead and twist this a little bit, you're going to see that the longer the lines, the smaller the radius. Okay, so that's indicating that this is a particularly tight radius because these lines are long. The more gradual, the shallower the radius, if you will, the shorter that line is. And this guy right here is where this line kind of flips direction, and that is referred to as an inflection point. Okay, now sometimes these things are very, very handy in trying to duplicate curves and specific radii and things like that. You'll notice if you go and try and do this on your system at work, your lines are going to be, these lines are going to be yellow. I changed the color of them on mine to red just because it's a little easier for me to see and a little easier to work with. Okay. All right. So let's get into some reverse engineering now that we've got this all under our belts. And let me go in here and say, close all of this stuff. Okay. So you've gone out, you found your part. In this case, Don has gone out and picked up that part that he wanted himself. He laid it on a bench top, stood right over top of it, so he got a nice planar view of it, and he took a digital photograph of it. Now, he's got this photograph, and what's he going to do with it now? So in this case, we're going to go bring that thing into SolidWorks, and it first and foremost needs to be saved as a JPEG. JPEG is perhaps the best, but you can use a bitmap too. JPEG is better because it generates a little smaller file size. So in this case, what I'm going to do is create a sketch, just like that. Now that I'm on a sketch, I'm going to go ahead and import the picture, and I need to use this tool right here. So maybe a good question is, where do you get that tool? So let's back the truck up and talk about that. I need the tool sketch picture. And as you can see, I'm in a sketch, and sketch picture is not available here on my toolbar. So I'm going to go get it. I don't know how many of you are familiar with this little search command tool, but this is one of the best things since sliced bread that SolidWorks has created. And what I'm going to do is come in here and go look for the tool sketch tool line, or sketch something or other. I know it's a sketch something, so I'm just going to type SK, and here come all the sketch things. Okay, and there's sketch picture. Now, if I just want to know where the sketch picture tool is, and then find it that way, I'm only going to use it this one time. I'm going to come over here and put my cursor right on the old eyeball here, and I'm going to left click without moving my mouse. Okay, so my cursor is here. Watch where the cursor is going to end up. but I'm going to left click on that eyeball. SolidWorks is going to show me where this tool is, opens up all the cascading windows, and there is this giant red arrow saying it's right here, okay? And notice that my cursor is sitting right in the middle of that box, ready for a left click, and it executes the tool. Okay, but let's say we want to, if I want to execute the tool itself right from here, I can just click on the words here. But if I'm going to do this once or twice or a couple of times, and I want to put this tool on my toolbar, I'm going to left click on the icon here, drag it with the left mouse button down, drag it and drop it up here on my toolbar. Okay, so here I am in a sketch. I have a sketch picture already on here, and I'm just going to left click on sketch picture, and then I'm going to drive to where my sketch is. Now in this case I have a cheesy little fleur-de-lis, but if you had like Don's part or another part that you had taken the picture of, this is where it would be sitting. And again, you would be importing the JPEG into SolidWorks. And that's what SolidWorks is going to be looking for. So I'm going to select it and say open. And here it comes. Now this is real time, so it's going to take a second or two for it to bring this thing into SolidWorks. And bam, there it is. Okay, so the sketch picture brings in the picture, that the photograph that I had taken. My JPEG is right here. If you look at the property manager, it says that it positioned the picture at right on the origin. The corner of the photograph is on the origin, so it's at 0x and 0y. You want to put a little angle to the dangle, you can do that by changing the angle right here, but I don't want to do that. It's telling me that my photograph, or the image that it brought in, is 57 inches by 60, almost 63 inches X and Y, okay? Well, the fleur-de-lis that I want to make is only going to be 12. That's my magic dimension, okay? I measured 12 inches from top to bottom. What am I going to do with that? The tools right here that are enabled by default are most helpful, okay? The first one is enable the scale tool. That's this thing that looks like a spear sticking in the middle of my image. And the other one that is of most interest and value is lock the aspect ratio. So when I start pulling and tugging on these corner points, everything is going to move in unison. So I'm going to take this guy, and I know that I want this thing to be about 12 inches from the top here to the bottom. And I'm going to use this tool to make that happen. I'm going to grab this end with my left mouse button, and I'm going to put it down here about the bottom of there. Then I'm going to come over here and grab this guy, and I'm going to pull that up to the top over there. Now it's telling me that that's, as measured, is 58 inches. I don't want 58, I want 12. So I'm going to type 12. And bam, it's gone. Ha, no, it's back. So what this has done is taken this picture and scaled it proportionately. And what I'm going to do with this guy is bring him back here to put him onto the origin. Okay. Green check. That sketch, I'm going to jump out of that sketch. Okay. And I'm going to define that sketch just for my own sanity and reference as, I'm going to rename that as picture. Okay. Okay, so there's my picture. I'm going to trace it. So if this is your simple planar part, you've got the dimensions maybe between a couple of holes or a top to bottom. That dimension really wants to be something large, something overall, something critical perhaps. You know, again, it can be adjusted afterwards, but overall is good, so you get a good reference to the overall dimension. So what I'm going to do now is create an additional sketch right over top of it. And the first thing I want to do is create a center line. Okay. Now guess which tool I'm going to use to trace this. First one that said spline, you're absolutely correct. So I'm just going to grab a spline, and here's my game plan. I'm going to sketch half of this. I'm going to trace half of this. And then I'm going to use mirror entities to mirror this half about this center line to this half. So that being said, the most critical thing for me to do right now is to make sure that this point and this point end up on the center line so I can get a nice complete and closed sketch. Okay, so I'm going to start there, put a point over there-ish, and a point over there. So at this point, it's a matter of using these control handles to drag this over top of the part that I just sketched. Or I'm going to create a sketch over part of the tops of these lines. Now, all of this stuff is movable. Sometimes I want to do this with a little more finesse. And the accuracy is going to be a function of your patience. Now, in these guys right here, it's going to be important that as I bring my pencil to here, you see that coincidence symbol? Again, least number of clicks possible. If you have to go more than 3, even for shapes like this, it better be something that you can justify. Otherwise, you'll be taking them all out of there. These are the times when you're going to see some points and the difference in playing with these little features here. This is all one sketch. Starting to feel like Bob Ross. Put one there, one there, one there. And it's a shape like this that actually helps you appreciate the fact that these controls are emanating from this point. Otherwise, this line would be like impossible to control. All right, so I have a coincident there and a coincident at the top. And now you're going to see why you want these things to be on in separate sketches, because even as long as I'm inside of this sketch, I'm going to come up to the original sketch picture and turn it off. So now you're looking at what I've got here all independent of that. And I'm going to box select these. Say mirror the entities first. Box select those. Mirror it about what? About this guy right here. And what's really going to be nice, even though you see this on here, is shaded sketch contours is on. If I've done this correctly, when I green check out of this, this whole inside should be a shaded gray color like that. That means there's no gaps, there's no extra lines, and everything is great. So what I'm going to do at this point is extrude it. Let's go mid-plane, about 3/4 of an inch. Let's put a little draft on this. That's fine. And there's my fleur-de-lis. So now I'm going to put a little, maybe. I had a student in a class a couple of years ago that insisted that this word says fillet. So I'm going to put a fillet on this side and a fillet around the other side.
You know, I like fillet.
I know. So we can dress this off a little bit. There you go. Reverse engineering from a ugly picture, maybe, but there it is. So that's it. That's the key to this. And as you can see, the reason why that one dimension is so important is to make sure that you get the scale correct. And the aspect ratio stays the same, so that digital imported photograph is golden, is important, is very, very important. Okay, so what I'm going to do right now is...
Paul, there's a couple questions. If you want, do you want to answer any questions at this time, or you want to wait till the end?
I do, and I wish there was something that I could just... go ahead. Let's go with the questions.
One of the questions is how did you pull up the equation-driven spline box?
Where did that box come from? I can show you the starting a sketch. Okay, so here are my sketch tools. Here's my spline tool if I go back old school, and there is equation-driven curve. Okay, so when you hit equation-driven curve, that's where that curve is coming from. Did that answer your question?
That was for Matt. I think it did.
Okay.
And then Ray Folks made a comment that it's good for the cam follower so that you can use the tangent mate. So for people who are using CamWorks or help with the manufacturing side of it too. And also we've got another one down here that says, can the drafts to the center, my boxer so I can see the whole thing. Can the drafts to the center and create an edge around the form? It's not all spelled right, but I'm not sure what he's at. Can that be I think it's spell check thing. Can that be drafted to the center and create an edge around the forms? So
sure it can. Are you referring to the Where am I in here? Let me get out of this. Drafted right to the center here like this is, I'm sure, I think that's what he means. Yes, you could do that. Just a different kind of a fillet.
David had a question. Did you fully define your fleur-de-lis sketch?
No. No, did not. Mm-mm. So when you do something like this, if I were to hand this out to 10 different people and have them do exactly what I did, they would be slightly different, each one. Okay, that's the beauty of it. In fact, when you do the sketches and you can see how of that little block that's created from the JPEG image, how tiny the line is in there to be dead nuts accurate in the middle of it ain't going to happen, because that little line could be anywhere within the range of that imported image line. So there's going to be slight, ever so slight variations, but understand how slight that is.
Are you able to unmute him, Paul?
Yes.
I think it might be easier I can just call our names. They can ask you the question better. Ray Folks has got another question for you. That's what the split spline is, what he said. So, can you unmute them all, everybody, or do you just unmute individual ones?
I'm in the process. Here's the process. I am allowing you to talk.
Ray, can you? Ray, I think I unmuted. Ray, are you able to talk? I think I unmuted you. Ray.
Now, I'm giving everyone permission to this sounds so freaking arrogant. I'm giving everybody permission to speak. All right. But you have to unmute yourself. Okay. And looks like you figured that out, Jefferson. Okay. Unmute yourself and then we can all hear you.
Anybody else have any questions?
Yeah, this is Rob. Can you just use fully defined sketch to complete your spline?
You can, and in many cases, that's going to give you sometimes all of it, sometimes some of the dimensions, but it gives you a start. Yeah, fully defined sketch is a nice tool. It doesn't work as efficiently, as thoroughly on splines, but it is a pretty good tool. Really nice shortcut for other images that you have to import. Good question.
Was there another question?
No, this is Ray.
Mm-hmm.
I was just talking about a fit spline. That works well. You were saying on the, excuse me, on the, it's a good application. I was running it the other day. I used a fit spline to create a surface without tangency lines.
Mm-hmm.
So I could actually, put a cam follower in and have a tangency mate where I could have some motion.
That is probably the single best use of fit spline, because when you're running a cam and a follower, oftentimes the geometry or the modeling of that gets hung up on those individual surfaces and it stops. So fit spline gives it the opportunity to run smoothly all around cam surface. You're absolutely right.
Yeah, it seemed to work, and it worked better than like a path mate also.
Yes, absolutely right. Oh, this is where I want to do the
Matt had a question. He said, since you're doing splines, is there a good way to design your spur gears in SolidWorks?
Ooh, I've never done that, but I would like to think it is.
Matt, have you ever tried a product called Gear Tracks?
Yeah.
That's something a lot of customers have used if they're designing a lot of gears. it helps with that geometry creation a lot, very well. It's called Gear Tracks, GEARTRAX,
or cam tracks.
or Cam Tracks.
It's all from the same family.